Okay. Let me just read what the question is again. Okay. So the first thing that the question wants you to do is it wants you to define an object, right? Called tic-tac-toe. So this is how you define an object called tic-tac-toe. Everyone should be good on that, right? Cool. So the specs say that it wants there to be a board property on this, right? So the board should be an array of arrays, right? And you could see how I'm doing it like this. You could start to see, once you fill it with null, it kind of looks like a tic-tac-toe board, right? So this is the board. Cool. So now the move function. What is it's a function, returns the board and adds the given character. Okay, so now we're going to define a method in this object, and it's going to be called move. So when you define a method, it's always going to be a function. Right, and that's how you define a function. And since this is the key called move, it's going to be the name of this function when you call it, or the name of the object method. And then this function, it's saying, is going to take a letter, and it's going to take, is it row first, I guess? I don't know. So it's going to take letter, row, and column, right? So it's saying, like, okay, if I want whatever letter you're passing into this to be at row, does it take an index or does it take an index or oh, okay, no, it's just the number of the row. Okay. Well, no, it is the index. Okay, cool. So this is like an index of the array. So if it was 0, it would be here. If it was 1, it would be here. If it was 2, it would be here. I think, if I'm understanding this question correctly. And basically, first we want to, there's two things you want to think about when you're actually playing tic-tac-toe, right? You can't put your piece in somewhere that somebody else has already went, right? So that's the first thing you should check for. You should check and see if somebody put like a letter at a certain place. So you say if, and you can say this dot board, because remember that this is referencing tic-tac-toe because it's inside of this object method, right? Does everyone understand that? This dot board at row at column. Oh no, whoops. At column. And if you guys remember, when you guys were learning about arrays, since this is a multi-dimensional array, it's an array of other arrays, you first access the row, and let's say this is 0, so it would access this array. And then there's another set of brackets here, and if this is a 0, it would be here. If this was a 1, it would be here. If this was a 2, it would be this null. Does everyone understand that? So if you're saying if this is equal, or if this is not equal to null, and if it's not equal to null, that means somebody made a move there, right? So if it's not equal to null, we're going to, well actually no. So if it's, if it is equal to null, If it is equal to null, we'll put our logic inside this if block, what we should be doing. And if it's not equal to null, then we'll just skip over the entire if block. That's easier. That's like more logical to put like this. You guys agree? Like saying, hey, if there's nothing here, we'll do some logic. But if there is something there, just skip all of this code that's about to go in this if block, right? Cool. So then, if you guys remember, with arrays, if you have the index, which we do, we have row and column. If we have the index, we can just say at row, at column, which should be null, and you could just set it equal to letter. And then here, you could just return this dot board, because I'm pretty sure the question wants you this to return the actual board. So, if you pass in, if somebody makes a move and makes this an X, right? And then they put in the same thing, like the same position, they want to change something. This if statement is going to run, and it's going to say, hey, let me check and see on this, which is the object, of the board, which is this, at row, which is this, at column, which is that. And it's going to say, wait a second, this is not equal to null. So you're just going to skip this logic and just return the board. Invalid move, just return the board. Does everyone get that? Who doesn't get this? What don't you understand?
Just trying to follow you
Okay, I'll explain it again. So, well, let me change this back to null. So you understand that on this object tic-tac-toe, there's a key board, right?
Yes.
And that key's value is an array of arrays.
Yeah.
And it's just all nulls, right? It looks like a tic-tac-toe board this way, right? Yeah. So now, we want another key on here, move, but its value is a function, so move is now a method that you can invoke. And we're defining this function in a way that you want to pass it a letter, X or Y, X or O, which row you want to put it in, and which column in that row. So we say, hey, this dot board, forget everything else, this dot board is referencing right here, because this is inside of this object method, so it's referencing the object that method is inside of. So it has access to this exact board. And it looks at row. And if this is a 0, it would be looking at this row. If it was a 1, it'd be looking at this row. If it was a 2, it'd be looking at this row. So let's say it's a 0, looking at the first row. And then it looks at the column. So let's say that's a 0 as well. So it's looking at this null right here. If that was a 1, it'd be looking at this null. And if it was a 2, that one. And that's how you access a multi-dimensional array. Like this, bracket first, and then bracket the second. So this bracket goes into this outer array. It says there's 3 things here, 3 arrays. What accesses the first array with row, and then it accesses one of the values inside of that array with column. And it's saying if it's equal to null. If it's equal to null, that means that nobody has played a move into that square, into this index here. So if that is, then you do the same thing, this dot board of row of column, which is this value, and you just change what it is. You put the letter inside. You set this null value equal to an X or an O, depending on what you're passing in. If it's not equal to null, you know that it's a letter. So this if statement breaks, the code inside of it doesn't run, and you're just going to return the board. So no matter what, if it's a valid move or not, you're just going to return the board as is. A little bit more clear?
Yeah.
At this point, how does our program know that row is referring to like 3 rows of these null arrays?
I just chose to call that parameter row because so you can visually see. You can call that whatever you want, but essentially row and column will be indexes. indexes of this array. So it's saying, like if I say index 1, index 2, this dot board at index 1 will be looking at the indexes of the outer array, right? Which are arrays. And then with the other bracket right after that, you put in another number, which should be an index of one of those inner arrays, wherever you grabbed it the first time.
Have we defined any of that yet, though? Or like,
What do you mean
how,
define it?
how do I list?
Well, like row is a parameter, so when I'm calling move, I'm gonna call this with a string x, 0, 1. I'm gonna be defining what that index is when I call that function.
Yeah, I get that. You have to like put something in this. This is just the space for the argument that needs to be passed into the function.
Correct.
But like these aren't reserved words, right? Row and column.
No.
So yeah, I mean, I guess I wasn't confused before, but just when I thought about this, I was just like, how does it know to like reference the different rows of that?
Well, because it's calling it off of this. You get how this dot board is referencing this. When you say this dot board, it's referencing the board value, the value of the board key.
Okay, so it's the this dot board bracket row bracket.
Yeah. So this
And
dot
it
board.
ties those two together.
Yeah.
Okay.
Like this dot board gets this multi-dimensional array. At the row is which index, which array, and at the column is which value inside of that array that you decided to pull out the first time, which row.
Okay, yeah. I think that makes sense.
It's a little weird to wrap your head around, but like it's the logic is there. You know, it's there. Just think about it, roll it over a bit. I promise you it's there. So what, did we have to do something else?
Yeah, can you go on that backward one, please?
No. For this problem, there's another thing. Is there a clear thing?
Just because the
And I'm guessing you just need to clear. You just need to do this, right? Just return an empty board. That's pretty simple. So this is going to be a function. Whoops. Shit. Did I mess something up? Okay, cool. So this is going to be a function, and you're going to say this dot board is equal to that. That's literally all you do. And then at the end, you just return this dot board. Does everyone get why that? You know, you're just saying, hey, this dot board, forget about what was there before. Just put an entirely new array of arrays with all null in it, and then return it. If you wanted to, you can like access this, loop through each thing, change it back to null. But why would you ever do that if you could just reset the entire thing, if you know exactly what the cleared board looks like? Cool?
I had the thing that tripped me up that I get doing the null thing. I was able to get it, and I did like a bang operator right before this, like on the first if statement between
Here?
this. No, one more out.
This?
Yeah, so I did a bang operator there, and it all worked. But I wasn't sure why I did a bang operator, like why that worked until like basically does that just make it equal null?
So
That's what I did. I kind of got it to work. I lucked.
Oh, wait. Well, I think this should work because okay, so do you guys know about? Does anyone know about the bang operator?
Yeah.
Yeah. So you're saying that an if statement runs if whatever you're passing into its parentheses is true, right? Correct. So this is saying if it's null, triple equals null, it's true, right? A bang operator basically says, okay, if this is a false value, if there's a bang in front of it, it's true. If it's a true value with a bang in front of it, it's false. So this dot board of row of column is actually equal to something. It's not like you're referencing something. This is like This is like looking at something and it's saying, hey, like this is if this dot board at row of column is null. If it's not null, it's going to be a string, and a string is a truthy value. So if you just put a bang here, you could do that too. And it's kind of like reverse logic, but it's still
That
okay.
makes sense.
I use bangs all the time. It's like definitely okay to use bangs.
So that this dot board row column thing should resolve to truthy values? You're saying?
In this
And so then
situation,
the bang will make it false.
no, yeah, no. So this should, for this line to run, for line 10 to run, whatever's inside here should be truthy.
Yeah. Were you saying that? So adding the bang makes it resolve to truthy rather than false.
Adding the bang makes it resolve to truthy if the value of this dot board in row of column is null. Because null is a false value. And that's exactly what we're looking for. We're looking for null. We're not looking for like a string or a number or anything. We're looking for exactly null, which is always false. And if the person using this is always putting in like strings of x and o, now like undefined or something, then this will be fine.
Null is just like a placeholder here, right?
No, null is data type.
I mean, not
Oh well,
not in
here.
this specifically, but in the array.
Yeah, it's just a placeholder. Like you could say like, hey, like no one made a move here yet. There's nothing here. No.
Are there other like placeholders you could use instead of null, or is that pretty standard?
Well, the null is pretty standard. You don't want to put like undefined in there. You could put 0 in there if you wanted to, but like why? Just put null. And since I think the specs on CodePen were specifically looking for like null values, so. Does anyone want me to do another problem from last night? You want the Taco Cat ink thing? Okay. Let me just reread. Oh yeah, so here you have. Okay, so they give you an object of objects of objects. So right away, it's really annoying. And then you have one thing cache at the end. So basically, hold on. So, oh wait, let me copy and paste that object so we can reference it here. One second, sorry. Okay. So we have this like crazy looking object Taco Cat, right? And what it's saying is it wants you to add what? What are they called? Okay, so it wants you to add a current inventory method to get what does it want you to do? What does current inventory do? Oh, how much everything is worth. So it just wants you to look through all of these things, multiply 2 and 100, multiply this with this, multiply that with that, that with that, that with that, that with that, whatever. So that's what you have to do. So you have to find a way to go through this entire object, but not cache. So, ooh, tricky. So let's figure this out. So first, we could say Taco Cat Inc. .current inventory is equal to a function, right? You can define it this way. You don't have to put it inside of this object. You could do the dot notation like this. It's the same exact thing, I promise. So you say it's a function, and you don't have to pass anything into it. It should just access this object and give you what you want, right? So you could say, if you wanted to be fancy, you could use this keyword. So let's do that. So we could say for let's what are gourmet shell is food types. in this, right? So this is a for in loop, as I hope you guys remember. It's saying it's every time you're looping through this object because we're passing it the this keyword on the right side of in, and this, which is inside a method of TacoCat, is just going to be a reference to TacoCat. And you say you're defining a new variable food types, and that's going to be the key every time. So, since the first thing we know is that if we ever happen to see this cache thing, we just don't want to even look at it. We don't want to address that, right? So you could just say like, you know, if food type, we'll make that. If food type is equal to cache, you can say continue. Sure. Continue means basically skip everything at the rest of this for in loop and go to the next thing, if you wanted to. You could also just do if it's not equal and then put everything inside that if loop, but this is a lot cleaner, so I'm going to leave it this way. Everyone knows about continue, right?
Continue jumps to the next thing?
Yeah, like, forget about for in loops, like for loops. Let's say you hit this if statement in a for loop and I was 0. Everything underneath this if statement, if it hits continue, everything underneath it would not run, and it would just increment I by 1. It would just skip everything and just still continue the for loop.
So it will skip that current.
That current, like, iteration. Yeah, that current loop. It wouldn't break the loop. It would just current.
It'll just go.
Yeah, it'll just go to the next. Yeah, it'll just keep going to the next one, but it'll skip everything below it.
Okay.
So now we can pull out. So now since this is an object and every single one of its keys is an actual object, so we could pull out that object. So we could say let type equal this at food type, right? So now, every time we're going to have access to this, and then this, and then this. Skipping over this because that does not meet this. So now that we have access to that, what we want to do is do another for in loop. And this say we'll say let food, let food item, I guess, in type. Because type is an object, right? And we're no longer referencing this, which is this entire object. We want the actual object we're on inside the outer for loop. So now that we're going, now we can loop through this whole thing, correct? Does everyone see how that's happening? And then we can say let, we could say let current item equal type at food item. So you set the current thing you're on, and then you could just say total plus equals. Did I define total anywhere? No? That's my bad. So before you do all these things, we should do let total equals 0. And that's just something we're going to add to the whole time. Then you say total plus equals. You could do this in parentheses if you want or not. You could say total plus equals current item dot cost times current item dot quantity. And then, outside of the outermost for loop, you can just return total. Where? Thanks. So now, if we do console.log of taco cat inc dot current inventory, we should get 1710, which is the answer. Who has problems with everything that I just did? Who has a lot of problems right now? Tell me. Does everyone? Okay, let's look at the actual object again. Wait, where is it? Does everyone agree with me that this whole object, Taco Cat, has 5 keys? 4 of those 5 keys, their values are also objects. This one, so we don't want to even look at this one, right? Cash. We don't want to look at cash, right? We want to look at all of these things inside of these objects. So we have to loop through objects, you have to do a for and loop. So we can grab these objects and skip in cache. Then once we have one of these objects, since they're objects, we should do another for and loop. Then we'll have access to hard treat shell, soft treat shell. And these two are also objects with a cost and quantity key inside of them. And since cost and quantity key is never going to change, we can access those with a dot notation, dot cost, dot quantity. So you have to do 2 for and loops to solve this problem. Yeah. So first thing first that I forgot to do, you set a total variable, set it equal to 0, because that's just what we're going to be adding to over and over again. And then you do a for and loop through the entire Taco Cat object, which you access with this, because it's inside of method, so it's accessing that object, right? Everyone understands that, right? I hope you do. First you check and see if it's cache, because we know what the object is, we can just say like, hey, is the key in this cache? Is that the current thing? If it is, continue. Don't do any of this code. Just go to the next key. And once it is on the next key, you say, you pull out that value. So this, at that key, would be this type. So this would be at all the other 4 bigger objects, right? Then you take that bigger object and you do a for and loop in that object. Food item, it would be the key, and type is that object. So you say let current item would be type at food item. So that would be one of those smaller objects with the cost and quantity key on it. These are both numbers, you multiply them, and you add it to total. And at the end, after the outermost for loop is done, for in loop, you return the total, and it's fine. Cool? Yeah?
It's saying that I punched all that in like while we were doing all like the testing, and it's saying that it still has like half of the specs are still failures, and it said in the instructions that there needed to be 2 methods.
Well, yeah, I'm not done. There's another.
Oh, you're not done. Oh, I'm sorry.
Yeah, bro, this is one method. This is one method. This is one method.
I see.
No. So now there's the sale function. The sale function is different. So we can do the same thing right here, right? Taco cat inc dot sale equals a function. But this time, this is going to take something. It's going to take an order. So what does this question even want me to do? So I think the order is going to be an object, right? Yeah. Okay. Yeah, this is kind of an annoying problem, but like it's going to be okay. So we could just say like, let final price, let final, it's cleaner, equal to 0. So we know that, wait, hold on. What is this? What does the object look like again that it's going to be in? Okay, so the order is going to be like, it's going to be an object and it's going to be, okay, cool. So first, we're going to look at the order. We're going to do a for in loop for let current order in order. Cool. And then we'll just pull out the current variable so it's more clear for you guys, like current equals order at current order. Cool? Then you could do final plus equals this at current order, I guess. At yeah, this is bad naming. I'm sorry. So we could do like let order key maybe okay, yeah, just leave it at order key order key order key, and then this we could say current order. Okay? Sorry. So this is saying it's going through that order, which here I'll just copy and paste what that might look like. Right? So the order is going to look like this. It's going to have all these keys with all these things in it. And these things are here, right? But we're going to have gourmet shell, gourmet fish filling, gourmet veggie, which is right here. You know, like they're the actual keys of the outer objects. So what I'm doing is I'm saying I'm going to loop through this object order, and I'm going to pull out each one of these, like soft shell, treat, tuna, catgrass. And since we still have the access to the actual object, TacoCat Inc., right? Because this is a method inside of TacoCat. So we can access that object, this, look at the property order key, which is going to be one of these, right? Each time you're looping through this, one of these, each time you're going to look at that bigger object, look at that, and then you're going to look at one of these. So now that you have that actual smaller object, you can say plus equals dot cost. Cool? And then now we have to actually alter the cache value, I think. And since this is inside of TacoCat Inc., we can access cache like that, this .cache. And what we're doing is we're just adding this at order key at current order .cost. Because now the TacoCat Inc., that company or whatever that you just bought some food from, is going to have some more cash. And it's going to be the cost of the thing you just paid for. Oh, but this should be inside. This should be inside the loop. That's my bad. Or if you wanted to, you could even leave this out. Oh, or if you wanted to, you can leave. Why does it keep happening? If you wanted to, you can leave this outside, but it won't be able to that. It would be this .cache is equal to final. Cool? I think that should still work. So now that you added to the cache, we need to. Oh yeah, you need to update the quantity, because if you bought something, then it's not going to be 100 anymore, right? It's going to be 99. So what you're going to do is still inside this for in loop. So for each time you buy something, you're going to say this at order key at what do I call it? Current order dot quantity minus equals 1. Or shorthand, minus minus. Just like plus plus, there's a minus minus. So now, if you console log this at sale of order, right? Yeah. Oh, it's not returning anything. And then you, so if I do this, and just console log taco cat, you'll see that treat this is 99, this is 99, cash is 8.1, so it works. Cool? I don't think so. So let's go over it again, yeah? Everyone can see, right? You guys in the back, you guys can see? Cool. So you see this function, sale, is an object method. So we're gonna do it like this, tacocat.sale is gonna be equal to a function. That means sale is now a method on tacocat. And this function is gonna take an order. So we set order as the parameter. And every time an order is coming in, it's gonna be in this format. It's gonna be an object, and each key will have a value of a string. So if you remember the actual tacocat object, which is right here, it's not really readable for you guys right now, but gourmet shell, gourmet fish filling, and gourmet veggie are keys on the out on each of the bigger objects inside of here. So if we just loop through this object, like we're doing here, let order key in order, first we pull out what that is, order key. So now we have soft treat shell, right? So that's what current order is the first time, soft treat shell, right? Then underneath that we do final plus equals this at order key, because remember order key is going to be still gourmet shell. Since we're defining that here, order key is gourmet shell. So this at gourmet shell, and this is referencing tacocat because this is inside of the method inside tacocat. So this at that gourmet shell is going to be an object. So at current order, which is soft treat shell, we set that right here. That will give us the object that actually has cost and quantity. So we just say dot cost, and you do that. Then, since we bought something, and we have, this is the same thing here, right? It's the same, this order key current order is the same, this order key current order here. It's that same object, and we know how to access it. So now, it also has quantity property on it. We subtract that by 1 because you just bought something. Okay? And this happens for every single thing that's in the order because it's inside the for loop. Then, to update the cash in tacocat, which is basically how much money tacocat Inc. made from your sale, you have the final here, this dot cash plus equals final, done. Who's got questions?
So just to clarify, to get the gourmet shell the order key to show up, you're using this.
What do you mean to get the,
console log?
what do you mean the order key to show up?
'Cause-
Oh, this?
Yeah, the order key.
Oh, yeah. Well, this thing on the right is the entire tacocat Inc. object after I make a sale. So if you look at the tacocat Inc. up here, it looks different, right? The quantity of soft shell treat here is should be 100, but since it was in that order, it's 99.
But what I'm asking is, how are you making it list? How are you making it show up as a list? The gourmet shell.
Oh, like here?
Yeah.
Oh, well, that's just the console. It's just console
I
logging.
didn't see that. Okay.
Oh, yeah. No, yeah. It's just the console.
And the current order, it says let current order equals, oh, I see.
Current order the first time going through would be at order key. So order key the first time going through would be gourmet shell, right?
Right.
So order at gourmet shell is equal to soft treat shell. And you set that equal to current order. Cool? And then once you have that, you can access the innermost object. Gourmet shell at soft shell treat, you can get cost and quantity. Cost and quantity off of that. Those are the only two things you need. Yeah. 79? Right. So 79, so logically, when you buy something from a store, they no longer have one more thing of that item, right? So, just like we got it here to get the cost of that thing to add to the final, we have to do it again. We have to get into that thing, get into that object, and subtract the quantity by 1. This is the same thing as saying minus equals 1. This refers to soccer carry, yeah. Yeah, it's just a variable inside the for in loop. Anything you put, so this whole thing is happening inside the for in loop, right? When you define the key variable to reference in the order, that is accessible throughout the entire for in loop, whenever it is. And it's always going to be gourmet shell or gourmet fish filling, gourmet veggie, or gourmet seasoning. Whatever keys are in the object, each iteration, it'll just go through everything. So if you know that, what the actual order is, and you know what the value is, you can get the cost and the quantity.
Order key is just a, I'm sorry.
I think I was going to ask the same question.
Order key is just a name, right? Like any.
Yeah, that's. Do you want me to change it there?
I think it was just confusing me because I didn't know if it was like a command that had good keys.
No,
Or if it was
no.
like, it's just you can call it, like I think in the example you call it category, it's just what anything.
Okay.
could be.
Yeah, I mean, I could call this category. It'll be the same thing. Like it's.
But order actually refers to that order object.
Yeah.
Okay.
And
Order see.
order-
What's up?
order key is just like, it just relies on the syntax of this, and order is the thing that's actually.
Yeah. So
walking this out.
when you're doing a for in loop, you do for let name your variable, whatever the hell you want, in an actual object. After the in, the object has to be real defined. If you try to do a for in loop on something that doesn't exist, there.
So to clarify, let current, line 77, let current order equals order
At
it's
order
key. Order key is it's pointing towards the soft treat shell when you say order bracket order key.
Bracket order key. Yeah, exactly. So this will be this.
Alright.
Because order key is gourmet shell.
Right.
So order at gourmet shell is soft shell treat, so that's current order. And this will go through every single time. So you'll get every single thing. It'll do all of this every time. Add cash to the end. That's it. You guys good?
Getting there.
Getting there? Should we start today's topic? Which is pass by value, pass by reference. This isn't too bad. It's a little weird, but like, it'll be okay. So let me just comment all this stuff out. So now, pass by value, pass by reference. So let me ask you guys something. Wait, just give me a second. One second. Right. So have you guys known, do you guys know about primitive values versus complex values? You do. There are 6 primitive values, right? What are they?
Strings, numbers,
Boolean. None.
No. The 6th one is called a symbol. Don't worry about it. And then there's two kinds of complex, and that's objects and functions. Arrays are technically objects, so arrays are complex as well. Now these things behave a little differently, and I'll show you an example of how they behave differently right now. So let's say let my string is equal to hello world, right? And then you say let other string, and you set that equal to hello world. So my string should be equal to other string, right? Right, it is. Hello world and hello world is the same exact string. But what if you set this equal to my string? Is it still equal? Yeah, it is. But what if you do this, and then you say, my string is now equal to goodbye world? It's false. Because you reassign my string to a different thing, and other string is still pointing to what my other string isn't pointing to anything. It literally says, hey, what is my string equal to? It copies whatever primitive value that is, which is hello world, a string, and it sets it equal to other string. There's no more connection between my string and other string. So when you reset my string, other string is still hello world, and my string is still is now changed to goodbye world. Cool? So now things are going to get weird. I'll show you this example. Oh, I'll leave this for you. I'll just comment this out. So now let's say let my array, and we'll set that equal to 1, 2, 3, right? And we'll say let other array equal to 1, 2, 3. So my array is equal to other array, right? No, it's not equal. And that's why they're complex. Doesn't make any sense. It does make sense. See, complex, they're not actually talking about what this is defined. These arrays are two completely different things. They're not the same array. They're referencing different places in the computer's memory. And that's why they're complex. When you're setting a variable to this, it's saying, okay, my array is now equal to this spot in the computer's memory, and that's an array right there. Then you say, other array is now equal to, I'm constructing another array, and it's equal to a different place. So if you set this, but now, if you set this equals to my array, now it is true. Because, oh, let me scroll up for you guys. That's my way. Because my array is referencing this object, right? It's not a copy. Like if this was a string, it would just be a copy. You're not making a copy of this array. It's just somewhere in the computer's memory, and it says, okay, other array, what are you equal to? I don't see a primitive value, like, and it gives you a reference, and it says, okay, here's this reference, go look it up. It's over there. So it's referencing the same thing. So now they're equal. So this could be dangerous. Let's say for some reason you want to do something like that, and you expect other array to remain 1, 2, 3, but then down here you say my array dot push undefined. Let me do this on a different line. As you can see, push mutates the actual array, right? You guys remember when you learned about push and pop and shift and unshift, that mutates the array, right? So push, you're calling on my array, 1, 2, 3, and you're pushing in undefined, just another primitive value, whatever. Arrays can hold whatever. So now my array is 1, 2, 3, but other array, this didn't make a copy at this point of time, and now they're not linked. This is still referencing the same exact array in memory, in the computer's memory. So, other array also gets changed, and that's why this is dangerous. And this is the same logic with objects as well. Reassigning values of keys. You'd be referencing the same object. Weird, right? Yeah. Well, let's go into the slides, honestly. There's not much more to talk about on my end that I could show you. Yeah.
Is the locational aspect the main difference between primitive and complex values, or are there other things? Like you were talking about the complex values, they have a location basically in the computer's memory, which is why.
It's all about assigning. It's all about assigning. When you assign a complex type to a variable, the thing that's being assigned to that variable is a reference to the place of memory. Whereas a primitive value, it's a copy of the value.
Yeah. So
That's the difference.
you said that the reference is
Yeah,
the location, and or
You'll get it at the end. You'll get it. So pointers and memory. So we'll talk about primitive versus complex types, variable assignment, passing values into function, equality operators, and passing values versus passing references, and arrays and dot slice again. So primitive complex values, like I said before, are strings, numbers, booleans, undefined, null, and symbols, right? Complex values in JavaScript are objects that include arrays and also functions. So let's take this for an example. So you say let British city is equal to York. And then you say let American city is equal to British city. Then you say American city is equal to a string new plus American city. Console log British city, console log American city. You get York and New York. Is anyone confused by this? British city is a string York. And you say, okay, American city is equal to this. Is equal to British city, which is equal to this, so this is equal to this. Then you say, now you're saying, okay, now American city, it's not York anymore, this is America, it's New York. So you say British city, American city, it's York and New York. Cool? So arrays are complex values, so if you say let British city is equal to an array with a string York in it, one thing in there, at index 0 it's York, and then you say American city dot unshift new, you pass in new to American city, console log British city, and you console log American city, they're the same thing because they're pointing to the same array in memory. Does everyone understand? I just showed you guys this before. Like you guys understand. This is the same example I just typed out for you, right? You're setting British city, you're setting American city equal to British city, but British city is equal to a complex value. So it's saying, okay, this value, hey, American city, this value, it's complex. I gotta give you a reference. So it gives it the reference. So now the reference is just one value. Like the array is being created inside the assignment to British city. So now there's a new array in memory. And then American city is just pointing to that same array. That's why unshift, like push and pop and shift, mutates the array. So now British city is also equal to New York, which you don't want ever, really. So why do primitive values and complex values behave differently? You'll be able to answer that question at the end of this lesson. So when you assign primitive values, the variable stores a copy of that value. So you just say let first is equal to 20. It's a number, right? An integer. It copies the value 20. Like you're writing 20 down. I mean, typing 20, which is a number. It says, and then when you define first, it copies the value of whatever you're writing, and it puts it into first. First is now pointing to this value. That's what first is. Now first, you're saying, okay, you're reassigning first, and you're setting it to a different primitive value. It looks at that value, copies what it is, and assigns it to first. And then you say let second equal 30. And then you say second plus plus. Now there's 30 and 31, right? They're not related, like, at all. Like, these are two completely different things. They're not related at all. If you increment second by 1,000,000, first is always going to be 30 at the end of this function. Yeah, at the end of this, by the time you're done reading the file. It's always going to be 30, no matter what you do to second. They're not related. What is this? Is this like the same slide? So if you say, okay. So if you say let first equal to 20, and you say let second equal to first, second stores its own value of that. It makes a copy of the value that's being stored at first. And when you increment second on line 4, it doesn't affect the value stored inside of first. It just doesn't, because it's a copy. It copies it, and it takes that copy. The original is left the same. First is not altered no matter how many times you alter second. It just doesn't happen. So now, when you assign complex values to a variable, the variable does not store a copy of that value. Instead, the variable stores a reference in memory. The reference then points to a value. And this happens with arrays, objects, and functions, okay? So if you say let first is equal to an array, 10, 20, it first stores an array. And it says the first variable is pointing to a reference. And you guys might be confused what this is. Usually like addresses and computers memory are like 0x0, whatever. Don't worry about it. This is basically like an address. So it says, okay, I'm going to look up the address now in this computer, and it's this value, it's this array, right? So first is actually not like pointing to, it's not actually pointing to a copy of a value, it's actually possessing a reference to a value that's somewhere else. Under the hood, that's what's going on. So if you say first dot push 30, it alters that array by looking into that, looking into the computer's memory and putting 30 at the end of first. So if you console log first, it's like that, you know? Everyone cool with that? But now, if you say let second equal to an array that looks exactly like the thing you're setting to first. These are different arrays, though. They're not. You're defining the array here on line 1 and on line 3. They're different things. So since first and second reference different arrays, pushing a value into second will not affect the array referenced by first. These values, first and second, are holding references to different arrays. So if you push 30 into second, first stays the same, as you can see here. They're different addresses. They're different places. These arrays are being stored in different places because they're different things. They're not the same. So it's still going to be 10, 20, and then 10, 20, 30. What's up? Is it right to say the order of the code doesn't matter? you're saying like if you're writing code and you like, no, I don't really know what you mean. What do you mean? Like if you have like a million lines, you have one thing pointing to an array, and then down the line you push into that array, and then down the line you want to access that first array. Is that what you're saying?
Yeah.
You can't do that. It's going to be the mutated thing. If you're
Right.
yeah.
So, but yes, the order does matter.
Yeah. So no.
Like,
Yeah.
just the form, you mutated it, then
No. Yeah. Okay. Yeah. So JavaScript is single. I forgot what it's called. Single-threaded language. So it runs one line at a time, right? So like, let's say you say, I'll show you here. So let's say here. Like it's still going to be, the console log is still going to run before you're pushing. Like like the way the program is running this code, it's line by line. So it sees on line 101, oh, okay, you're defining my array to this. Oh, okay, log it out in the console. Oh, okay, and then it gets logged in the console, and then it says, oh, okay, push more into it. Well, like we don't see that. So like, yeah, order does matter. I mean, it runs line by line.
Yeah, so with that other array, that's my array, and then you console out other array, and then you my array dot push 4, and then you console out other array.
You have to console log other array here.
Yeah.
Other array should be 1, 2, 3, 4.
Fair, I know. And then push something else into my array after that.
Here? Yeah, I mean, I'm pushing undefined into it right here.
Oh, okay, and then, okay.
Then if you console log other array here, it'll be have undefined. It just matters the order of like when you're doing everything.
Can you go back to that code page for a second?
Oh yeah, sure.
That line you just typed out, 109.
Yeah.
Can you delete that?
Oh.
Or comment it out or whatever yet. And then if you read console, where's that 5 coming from?
It's coming from here, but it should be this.
because my array dot push will return the total number of.
Oh yeah, it returns the it returns the length of the array. That's my bad. So if you remember, like if you set let what is this equal to equal to that, and then console dot log what is this? Oh shit. It's gonna be 5. Because push returns the length of the newly mutated array. Cool? It's confusing. Awesome. Right. So back to where we were. So you say let first equals an array 10, 20. Then you're defining a new variable second. And you're setting it equal to first. Second now stores a copy of the array originally stored at first. I mean, no, it's a copy of the reference. Sorry, that's my bad. So as you can see in this table down here, first was defined first, the variable stores a reference to what this is. But since you set second equal to this, first is this. First is this reference. So it's this reference. And it's the same reference, so it's the same array. Does everyone get that? What's up?
Is the reference copied, or is it?
The reference is copied.
The reference is copied.
Yeah.
Okay.
Like when you're like, if that was just the number 10, 10 would be copied, right? And you set second equal to first, it'd be the variable 10 would be copied because it's primitive. The value of that would be primitive. But since it's complex, this whole reference thing comes into play. And it's referencing it somewhere else. So when you say second equals first, second says, hey, first, what are you? Let me copy you. Just gives it a reference. So since the reference is the same, there's still only one array when you're doing it like that. First and second share the same reference to the same array. So when second.push is 30, first is also getting updated. So this is just kind of tricky behavior that you need to be aware of, especially when you're doing things with arrays like push. I know like push is a very commonly used method of arrays, but it does mutate the original array. So if anything else was ever being set to that original array somewhere, that thing is going to get updated too. So just be wary, be careful of that. So now this is where slice comes in, which is pretty interesting. So if you guys remember, slice returns a copy. It doesn't mutate, right? So if you just don't pass anything into slice, it just makes a copy of the array. So if you wanted to set second to what first is, but you don't want it to reference the same thing. You just want every single value inside of that array to be inside of the second array. So you can just say first.slice. And this returns an actual copy of that. An actual copy of everything inside of that in a different array. Slice goes into the array, and if you don't pass anything into it, it starts at the 0th index, and it copies every single value and returns something else. So second is now referencing an entirely different array. Does everyone get that? Cool. So now, if you're pushing 30 in, only second gets updated, and first is not. Because they're referencing different arrays. Because slice makes a copy. So now, let's talk about functions. How passing in primitive values, how passing in complex values could affect outcomes of functions. So let's say you define a variable mynum, and you set it equal to 10, which is a primitive number, right? And then you define a function adds 20 that takes in a number and just says num plus equals 20, returns that num. So if you set let return num equal to adds 20, it'll be equal to the return value of that function, which should be, if you put in 10, it should be 30, right? So if you console log mynum here, it's 10, right? And if you console log return num, which takes the number passed into the function, adds 20 to it, and returns it, it's going to be 30, right? Everyone's cool with that? This is a very simple function. You guys are good? So, what happens if you pass in a complex variable? So this is pretty much the same function, but my array is now not 10, it's an array with one value in it, the number 10. And the function is an adds 20, it's pushes 20. So function pushes 20 is always going to take an array, it's always going to push the number 20 into that array, and then it's going to return that array. So we could set the result of that equal to returned array, and we could console log both things. What do you think will happen? My array is now 1020 as well, because you're passing in a reference not the actual value. The value is somewhere else. So if you pass in the reference to that, my array is getting updated. So this returned array is actually referencing this in memory, because when you pass this into array, it gets mutated here, and then we're returning it here, and then it's trying to assign returned array to that, so it's saying, hey, I'll give you a reference to what I am, and then there it is. So it behaves the same way as I just explained. Cool? So triple equals will compare complex values by reference and not by value. So I'm sure maybe like in this week you guys have tried to do like triple equals to arrays maybe and gotten false when it doesn't make any sense. That's why. It's comparing them by reference and not by values. So if you let array 1, like I showed you, 1, 2, 3, 1, 2, 3, array 1 triple equals array 2 is false. They're not referencing the same thing. They're just not. It's just not what's going on. But if you set array 1, if you set array 2 equal to array 1, they should be true because they're referencing there's only one array over here. You're not making another array and putting it into array 2. You're saying array 2 is equal to array 1, which is equal to that. So array 2 is saying, hey, array 1, I want to be equal to you. And array 1's like, nah, here's a reference. So then array 2 just has like an address of where this array is in memory. So they're equal. It's the same exact array. Triple equals checks by reference. Double equals does not check by reference. If you went back to this slide, I should. One second. If you went back to this slide and you did double equals, this would be true, I think. So double equals is just kind of like I never use double equals because you never know what you're going to get. Even if you do a string of 1, double equals number 1, that returns true as well, which is bizarre because they're just not the same thing. So yeah, use triple equals all the time. That's like that's the best advice I could give you. You know. So we showed earlier that dot slice creates a copy, right? So now, if you look at this, array 1 is equal to an array. At index 0 of that array, it's 1. At index 1 at that array, it's another array. So this is a multi-dimensional array, right? So if array 1 dot slice should copy that, what about the complex value at index 1? It's still false. Oh no, this is false. It's still false because it's a copy. Because you sliced it. Even though you're not like slicing the thing inside of that. Even though this is complex, you're still slicing this. So it's returning a different copy of this entire array. The entire array is different, so they're not equal. Still. But if an array, so if an array has a complex value as an element, only the reference to that complex value is copied into the new array. That's why we say slice makes a shallow copy of an array. It doesn't make new copies of any complex value stored inside the array. So, like we did before, let's take a look and see what's going on here. So we say array 1 is that thing that we just showed, right? At index 0, it's 1. At index 1, it's 2 and 3, right? So if we say array 2 is equal to array 1 dot slice, it makes a copy of this whole thing, and it puts the reference. I mean, it doesn't make it. It makes a copy of the reference, and that is now this. So it's. Oh no! I'm sorry. I'm confusing myself. So slice makes a copy of this whole thing, and now this is equal to a new array member, right? Sorry, I didn't get confused. Everyone knows that that's happening here with slice. The slice returns copy of the array. But array at 1, array 1 at 1 is this array, right? So if you push 4 into that, and you console log array 2 at 1, that will be 2, 3, 4. And they're still pointing to the same thing. So in the previous slide, in all that text, it said slice is a shallow copy. Shallow meaning it's only the outer array, not any complex data types inside of the array. The things that are being copied in there are the references.
So if you did like array 1 bracket 1 triple equals array 2 bracket 1, you get true, right?
Yeah, that's what's going on right here.
Okay.
Even without the push, that would happen.
Yeah.
It's just showing you push to show you that array 2 at 1 is still updated, is being used. So like, yeah.
Yeah.
What's up?
So the point is, if you take array 1,
Yeah.
array, no, if you take array 2, it will also mutate array 1.
Well, in this specific example, if you mutate array 1 at 1 or array 2 at 1, both array 1 at 1 and array 2 at 1 will update. But in this example, since we're using slice on the outer thing, if you don't put the 1 in, then this won't be updated. I'll show you guys an example of this. So here, where's this console log? So let's say down here, say let array 1, and you'll set that equal to 1, 2, 3, right? And you set a let array 2 equal to array 1 dot slice, right? So now this is false, right? And everyone understands why now, right? Because slice returns a copy of the array. So if I made this an array, if I made this an array, so now it's number 1, number 2, array, right? If I made this that, and I said array 1 at 2 is equal to array 2 at 2, that's true. Because if you console log array 1, and then you console.log array 2, they're the same thing, because this is a copy. But the thing inside of it, one of them is complex as well, this 3, which is inside of an array. So array 1 at 2 and array 2 at 2 are 3, and they're pointing to the same array. But if you wanted to do array 1 dot push false, array 1 is the only one that false is being pushed into, not array 2. Because slice is making a copy of this whole array. So if you push into the whole array, the outermost array, that slice is being called. Slice is like there's a dot on this outermost array. So everything, so this is now, so array 2 is now a copy of this. It's not pointing to the same thing in memory anymore. So if you push in false, just this one gets updated, not this one. But if you pushed it into array of 1 at 2, which is this array at 3, this array will now have an index, have a length of 2, and an index 1 will be false. And since slice is only copying the outermost, returning a copy of the outermost array, the inside thing is still going to just be a reference. So if you try to mutate the inner array off the slice thing, it's still going to be pointing the same thing. Both things will be mutated. If I console log what? 115? If I just console log array 2? Yeah. There's no false in there because you're not pushing it yet.
How were those, if you put back what you had, like the strictly equals? I guess I'm confused with like how a is it one reference, so how are they strictly equal? Does that make sense? Maybe not.
These are strictly equal because triple equals compares references. Right? Right?
Right.
So, slice copies every value inside of the array. But since this is complex, slice is just copying a reference. So this array, inside of that array, will be the same thing in each one. So that's why it's true. It'll be pointing to the same thing in memory. It'll be pointing to one array. It's weird. This is like
Except they're not really strictly equal.
yeah, but like
They're
they are.
references. Right.
It's just something to be aware of if you're setting variables to arrays and then setting variables to those variables. Weird things will happen. So just be aware of them. Any other questions before you guys take like 5 minutes break? Alright. I'll slack out pairs. I'll slack out pairs at like 8:15. Take a little break. Something. What? Is it cool if I just like do the random pairs?
I've been tied up with people before where it takes such a different level, but it's just like
Yeah, but sometimes I could.
back or
No, but sometimes it's like good to like work with people like that.
I've been
You're
working with them before.
Okay.
Yeah, no, I'm like trying to work with different people and stuff. I just don't want to be accidentally paired with someone who's just like way young because I've done that twice and then I just like, don't learn anything because they just go too fast.
Yeah.
Like, I don't want to stop them.
Okay.
I'm Zach, your fellow.
Oh, okay.
Yeah,
I was wondering.
hanging out there. Yeah, strange guy. So is it okay if I go downstairs really quick, 5 minutes, and come back?
To do
Is that
it.
cool? All right, cool. Yeah, I think that's all that you need, right? Just help take this from that.
Yeah, help take
Okay.
so that's cool.
So
Thank you.
creepily sitting back there.
No, yeah,
Okay.
no, for sure, yeah.
Yeah, thank you so much.
No problem.